Okay, this is 13.4 vectors. Okay, so we did this one, and these were in the pre. We're here, and we have one more. Okay, and we did this in pre, and we are not doing this. Okay, so the objective for this section is so we did the distance formula and equation of circle in 13.1, right? And these you already knew. Review, and we are here. Okay, the vectors, and then we're gonna do midpoint formula in 13.5, and we are done with chapter 13. Okay, so understand the basic properties of vectors. Okay, vectors. All right, so here is the description of vector. The journey of a boat or airplane can be described by giving its speed and direction, such as 50 km/h, northeast. Any quantity such as force, velocity, or acceleration that has both magnitude, the size, and the direction is a vector. Okay, so the vector has the magnitude or the size and the direction. Okay, that's a vector, which is a little bit different concept from the geometry that we were doing. It was just the size and the shape, right? It was a size and the shape. The size would give you equal, and the shape would give you the similar and congruent and so forth. Now we're talking about direction. Okay, when a boat moves from point A to point B, its journey can be represented by drawing an arrow from A to B, like this. Now, you see, do you remember this? That's a ray, right? Ray AB, which is different from this. So that's a vector. This is the vector, this is ray, okay? And we read this vector AB, vector AB. If the vector AB is drawn in the coordinate plane, then the journey can also be represented as an ordered pair. So the vector AB is change in x and change in y. So, for example, this vector AB is change in x is 4 and change in y is 3. So vector AB is 4, 3. This vector CD is change in x is 5 and change in y is negative 2 because it's going down. So it's 5, negative 2. All right, magnitude of vector. Like I said, the vector is size and direction, right? So this will give you direction. And the size is the distance formula. So this distance right here is the size or the magnitude of a vector. So 3 and 4. So the magnitude of vector AB is the square root of 4 square plus 3 square, which is 5. And the magnitude of vector CD is 5 square plus 2 square, which is square root of 29. Now, even though this vector has a negative direction, the magnitude is, since it's a distance, and then this gets squared, this is still a positive number. It's not a negative number, because this is a square root squared number, so the negative disappears, right? Negative 2 squared is 4. I wish they wrote this like this. But anyway, you get a positive number. So the magnitude is always positive. Okay? So here is little example. So point P and Q. The sketch P and Q. Alright, so negative 5, 1, 2, 3, 4, 5, and then 1, 2, 3, 4. So here is a P, and 1 and 2. Here is Q. So this is the vector PQ, and PQ, the vector PQ is the x is going 1, 2, 3, 4, 5, 6, and it goes from 4 to 2, so that's -2, right? And the magnitude of vector PQ is the square root of 6 square plus -2 square, which is square root of 36, plus 4, which is square root of 40, which is 2 root 10. Okay, perpendicular, parallel, and equal vectors. Okay, two vectors are perpendicular if the arrows representing them have a perpendicular direction. Two vectors are parallel if the arrows representing them have the same direction or opposite direction. The opposite is also parallel, okay, as long as they are parallel, like this. And all the vectors shown in the right are parallel, so these are all parallel. Notice that OA and BC are parallel even though the points OA, BC are collinear, because this is not the same vector. These are different vectors, right? The magnitude is different, even though directions are the same. So these are parallel, okay? Two vectors are equal if they have the same magnitude and same direction. So the direction is kind of like a slope, okay? So in the diagram, BC and FG are equal vectors, because it has the same move, right? 1, 2, 3, 4. This is 4, and then 1, 2, 3, 4, and then 4. And this one is 1, 2, 3, 4, and 1, 2, 3, 4, right? So it's, and then obviously if these are the same, then this is gonna have the same length. So these are equal vectors. You can tell by using slopes whether the non-vertical vectors are parallel or perpendicular. Example 2 shows how, okay? So here is the example 2. Okay, now here is show that vector this and vector this are parallel. Okay, now this is not to be confused with, where is a good example here? Go up here. A good example. Is there any point somewhere? I thought there was P. So maybe here's a point P and point Q, right? So there is a name for the point and then a coordinate. Name of the point and coordinate. So if it's indicated this way, that there is a point, this and this, these are coordinate of the point. Whereas this one doesn't have anything in front of it, right? And these are no coordinate, these are vectors. So this vector is when x goes to the 9, and then y goes down 6. Okay, so slope of this vector is 9 over -6, which is -2 over 3, right? And this one, when x goes down by 6, y goes up by 4. So the slope of this is also -2 over 3, right? So these two vectors are parallel because they have the same slope. They don't have the same magnitude though, but they have the same slope, so they are parallel. So this one is just like these two. See, these have the same, so this is 3 and 3. This is 4 and 4. They have the same slope, so these are parallel, but they are not the same vector, an equal vector, because the magnitude are different. Okay, and okay, let's look at the perpendicular. So this one, when the x goes up by 9, y goes down by 6, so that's -2/3. It's the same. And then this one is when x goes up by 2, y goes up by 3, and this times this is -1, and therefore these two vectors are perpendicular. Okay, all right, scalar multiples. The symbols 2 times vector PQ represents a vector that has twice the magnitude of vector PQ and has the same direction. So if the vector PQ is 3, 2, it should not surprise you that 2 times vector PQ is 2 times 3, and 2 times 2, which is 6, 4. Okay? In general, if the vector PQ is A and B, then K vector PQ is KA, KB. You just multiply. You multiply. K, and then K vector PQ is called a vector multiple of vector PQ. I'm sorry, scalar multiple of vector PQ. Okay, and this is a scalar multiple. This is a scalar, and this is a scalar multiple of this. Multiplying a vector by a real number k multiplies the length of the vector by absolute value of k. So if k is less than 0, so for example this is minus 2, then you'd multiply by minus, and then minus, and then it's going to change the direction to, for example, this was PQ, and negative 3 PQ is going to go from here to here, if the k is less than 3. The direction of the vector reverses as well. This is illustrated in the diagram below. What ordered pair represents negative vector PQ. Okay, so this one, this vector is 3 and 2. This vector is 2 times PQ, so it's a 6 and 4, and let's check 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. Okay, now this distance right here was square root of 9 plus 4, which is square root of 13, right? And this one is square root of 36 plus square root of 16, which is a square root of 36 plus 16. So that's a 40, 52. So 52 divided by 2 is 26, and 2 and 13, so this is 2 root 13, and that's 2 times the vector, magnitude of vector 13, right? Now this one, this is when x goes down by 1, no, I'm sorry, x goes negative by, goes from here, so 1, 2, 3, 4, 5, 6, 7, 8, 9, negative 9. The y goes down by 1, 2, 3, 4, 5, 6, negative 6, and then that makes sense because this times negative 3 is negative 9, this times negative 3 is negative 6, and the magnitude should be minus 9 square plus minus 6 square, which is 81 plus 36, which is square root of, what is it, 7, 1, 111, 117, right, 20, yeah, so 117, you can probably divide by 3, and then 3, 9, 3 again, 1, 3, so this is 3 root 13, the magnitude was 3 times the original one, okay? Alright, and the sum of vectors. This is the last concept, and the rest is practice, okay? Vectors can be added by following simple rule. So this one was multiple, right? Multiplying. This one was multiplying, and the slopes are parallel, and the magnitude goes up by the multiples. This one's different. So AB, the vector AB plus vector CD is A plus C and B plus D. To see the application of adding vectors, suppose that a jet travels from P to Q, and then from Q to R. The jet could have made the same journey by flying directly from P to R. Vector PR is the sum of vector PQ and vector QR. We abbreviate this fact by writing vector PQ plus vector QR is vector PR. So 4, 1 plus 2, 3 is 6, 4, right? 6, 4. You add the x value and y value to get to this. Okay, so that's sum of the vector. So this vector plus this vector is same as this vector. Okay? All right, let's see practice. Name each vector as ordered pair. All right, so why don't you do these for homework? Okay, and the 2 says find the magnitude of each vector in exercise 1. So we're going to do these in video. Okay, so 1D, 1 and 2D. Okay, EF. EF is going straight down. So X is not changing, so it's 0. Y is -2. So that's the direction. And the distance, it's just 2, right? 1 and 2, C. C, where is C? BC. BC. Okay. So X is going up by 1, and Y is going up by 1, 2, 3, 4. Okay? And square root of 1 plus 16 is square root of 17, so that's the magnitude. 1 and 2 of F. AG. AG. Okay. So X went down by down. 1, 2, 3, 4. 1, -4. I just counted in Japanese. 1, 2, 3. It's going up by 3. So 3. So that's the direction of the vector. And the magnitude is 16 plus 9, which is 25, which is 5. Okay? And if BC is parallel to OD, X is BC parallel to OD. BC parallel to OD, you can do this one. Homework is BC equal OD. Homework, explain. You gotta think about how to explain it. What kind of figures is OBCD? OBCD. Okay, you can do this. Is AG parallel to OB? AG parallel to OB. You do this. AG equal OB. Ah, okay. Do these all for homework, okay? Think through it. And here is no problem. Refer to diagram, find ST, absolute value of the magnitude of ST, and tangent of S. Okay, let's do this one. So let's do just tangent of S, opposite over adjacent. So tangent of angle S is 4/9, right? And this vector is 9 and 4, so the distance is square root of 81 plus 16, which is square root of 97, and 97 is 97 prime 3, yeah, so that's it, square root of 97. Find each sum. Okay, so why don't you do this and this homework, and let's do B. Okay, all right, so you remember when you're adding the vector, you just add X to X and Y to Y. So 0 plus 7 is 7, and minus 6 plus 4 is minus 2. Okay, should I show you this in what it looks like? Okay, so X doesn't change, and then Y goes down by 6. 1, 2, 3, 4, 5, 6. So that's a first vector, right? And then the next vector is this way 7. 1, 2, 3, 4, 5, 6, 7. And then up 4. So 1, 1, 2, 3, 4. It's over here. Goes like that. And then I started from here. So the now new vector is this, right? Which should be 1, 2, 3, 4, 5, 6, 7, and down to 1, 2. So this is the sum of the vector. So it went this way and this way, and kind of went back. So the sum of the two vector is this. Okay? All right, so you do A and C. Find each scalar multiples. I think you can do this. This is not hard. And if PQ represents a wind blowing 45 kilometers per hour from the north, state two ways you could name the vector representing the wind blowing 45 kilometers per hour from the south. Okay, so this one, let's just say the north is this way and then south is this way, right? And then this is the vector representing the 45 kilometers per hour from north. Okay, and then so this is P and Q. Okay, so if the wind is coming from, but the same, this represents the magnitude, so it should have the same length, right? So you can go from the south to north, so you can say QP. So vector QP would do it, or you can go a negative direction this way. No, actually, PQ is this, and negative PQ would make this, it was going this way, and Q, so that would give this flip. If you do negative, it's gonna, Q is gonna go over here. Okay, the same magnitude in different direction, but still it's the same wind, the same force, and in the right direction. So these are the two ways to represent the wind blowing from the south. And just to show you here, okay, so if this was P and Q, then this is vector PQ, but also if you are scaling, this is not the same point as here, but it's 2 times PQ. This just represents a vector, okay, it's not the point. Vectors connecting 2 points. This just represents the 2 times the PQ is gonna go here. Okay, just like here, the PQ was this, but negative 3 times PQ is gonna go over here, right? So that doesn't mean that this is point P. It's just originally the PQ was this vector. So if you do negative 3, it's gonna go from P to this new point here. This is not P. It's just, this represents just negative 3 times the original vector. So that's why this problem right here, this was the original vector PQ. The negative PQ is gonna just flip the direction, and that's not a Q. It's just that this vector represents negative PQ. Okay, it's a little tricky concept, but you get it. Okay, and we do more practice in the class.